Hello and welcome again to my Physical Science online video lecture supplement series. In today's video, I'm going to be looking in the Mailbag, which is basically the things that have been submitted to me by email or by discussion boards within the course, and trying to answer whatever the question happens to be. Today's question has to do with significant figures, and it basically says, I'm confused on how many numbers we should round to when dealing with significant figures. I know that the exercises say 3, but when I do that I get them wrong, and when it does not say a specific number I use how many the equation has, I am still wrong. I'm really confused. Alright, thanks for the question. Let's see if I can give a response to it that is actually helpful to you. You'll notice that significant figures are discussed within the textbook that we use. Since I have the Shipman, Wilson, Higgins, and Torr's Introduction to Physical Science 14th edition in front of me, that's the one that I'll be making references to. And significant figures are actually discussed in section 1.7 of this textbook. They're also discussed in what I would call the third part of my first lecture on measurements. And basically what I say in the this lecture is significant figures are used to indicate the approximate number of digits to retain after a calculation. They are reliably known, and basically what we do is we exclude any zeros that are used to locate the decimal point, and all other digits, that is any non-zero digits, any zeros that are located in between non-zero digits, and any zeros which are located to the right of the decimal place, and any other digits count as significant. So I gave an example in my lecture notes which shows these 5 numbers and asks how many significant figures for each. So let's look at each one in turn. This one says the number is 109. And we are excluding any zeros used to locate a decimal point. There are no such zeros in this one. The only zero that we have is between two non-zero numbers, so that means that it is significant. And any non-zero digits are also significant. So we have 1, 2, 3 significant figures. So let's turn to this second number. If you counted the digits showing, you'd see that there's actually 5. But the question is, how many significant figures does this have? In other words, how many of these are actually significant? And we're supposed to exclude any zeros that are just used to locate a decimal point. So what's a zero that's used to locate a decimal point? Well, in this number, it's all the zeros. And the reason why is that you don't have any non-zero numbers on the left side of all these zeros. Basically, if it's a zero and there is no non-zero number to the left of it, then it's not significant. If it's a zero and it is to the left of the decimal place and there are no additional non-zero numbers to the right of it or zeros to the right of the decimal place, then it's usually going to be not a significant figure. So in this thing's case, there are no non-zero numbers to the left of any of these zeros. Therefore, the only significant figures are this 5 and this 7. For our next number, we have 4.00. So these zeros are not actually needed to locate this decimal point. If we took them away, we would still have 4. So that means that they count as significant figures. Basically, if you have a zero that is following after a non-zero number and it is to the right of the decimal place, then it is significant. If it is the last zero and there's nothing to the right of it and it's to the right of a decimal place, then it's also significant. about the only exception I can really think of to this rule is you could in principle measure something that was 0.00000, and in that case there's no real way to know which of those zeros are significant and which are not. But that's a very, very odd exception that you're almost certainly not going to encounter, and certainly you won't in this course. So the general rule is that if it is we'll call it a trailing zero to the right of the decimal place, and there's something to the left of that decimal place, or there's something to the left of that zero, then it's a significant zero. So this one has 3 significant figures. Next we turn to this number, 680.0. Well, this 0 is to the right of the decimal place, and there's non-zero things to the left of it, so it's significant. This 0 falls between 2 other significant figures, so that makes it significant as well. So this has 4 significant figures. Finally, we turn to 3200. 3200 is sort of an odd beast. The usual way that we'd say this is there's 2 significant figures, 3 and 2, because these 2 are needed to locate the decimal. The decimal would go right here. With that said, this is not actually a hard and fast rule. These zeros we usually, for convenience, treat as not significant, but in fact they may be significant. And to illustrate why, I would need to show you something on my whiteboard space. So let me pull that up. So here's the number 3200, and the question is, are these all significant or insignificant zeros? And the answer kind of depends upon what it is you're actually using to measure with. Let's say that you used for example, a meter stick. And maybe this represents 3200 millimeters. So maybe you have a stick that is 4 meters long and it's marked off. Well, what is it marked off in? Usually there's tick marks on it of this sort. So you look on your meter stick, you have all these tick marks, 1, 2, 3, 4, and there's a big tick mark, 1, 2, 3, 4, and then a big tick mark, and so on. Well, what do each of these tick marks represent? If the object is measured, let's say that the object, I'll draw it in blue for contrast. The object is maybe right here. Alright, so what does each of these tick marks represent? And that is what's going to determine whether these are significant or not. Let's say that this right here represents 3200. Alright, well, if this right here represents if this one right here represents 3300 millimeters, and this one represents 3100 millimeters, then these are not significant zeros, because if I were to have another object that was, say, this long right here, I would probably still write the length as 3200 millimeters. And if I had one that was this long right here, I'd probably still write it as 3200 millimeters. I might try to guess at what fraction of a millimeter this is, but if you pick up a meter stick, and since you are in my lab, most of you watching this are in my lab, you will pick up a meter stick or a ruler or some such thing, and you can look and see how big a millimeter is. You can guesstimate, but you're probably not going to get much better than plus or minus 0.2 or 0.3. Odds are it's going to be more like 0.5 or half of this increment. So in this case it'd be 50 millimeters. But let's say that all of these you'd record as 3200, and then you measure this beast and you say it's 3300. Well, you can't really distinguish, in other words, between 3200 and let's say 10 versus 3220 versus 3200 even. All of those you would have written out as 3200. That means that this is not a significant zero. So your significant figures are just these two. Now let's consider this process a second time. Now we have a different measuring device, and it's marked like this, and you can distinguish between each of these lines. So you have a object that you've written down 3200, and you decide you have a second object and you're going to measure it. Well, this one you probably still write down as 3200, but you might guess it at 3200.4. And then when you get out to an object that's more like this, you'd say, no, this is more like 3201. An object like this, you'd say, no, this is 3199 millimeters. In other words, you're able to distinguish the difference of 1 millimeter between 3200 and 3201 and 3199. With the other scale that I drew, you could not make this distinction. All of these would have been very clearly written down as 3200. So in this case, this and this actually are significant zeros, because you could tell the difference between 3200 and 3201 on the scale that you have. So in this case, you actually have 4 significant figures. With that said, the general rule, and this is the rule that your textbook gives, treats these zeros as if they are insignificant regardless of what you do. So that's basically significant figures in a nutshell. Now, to complete today's short video, what I want to do is actually look at an example. And so let me pull that up. Since we are using WebAssign in this term, I'm pulling up the one question of this from WebAssign. So this is one of your homework questions. It corresponds, I think, to question, presumably it basically corresponds to question 23 from chapter 1, or exercise 23. Could correspond to exercise 22 from the same chapter of your Physical Science 14th edition. In both cases, it gives you a set of 4 numbers and says round these off to 3 significant figures. And glancing at the 2 questions, I think this one corresponds more to question 23 in your text, just because these numbers look kind of sort of similar to the ones that I have for my hard copy of the text for that question. Be that as it may, let's go ahead and round each one of these to 3 significant figures. And you'll notice that I've pulled up a blank text document. That's because the answers would be shown if I just had this displayed. Mine shows the answers. And so I want to work this problem, then we'll look and see if our answers agree with their answers. Alright, so the first one says 0.9822, and we want to round to 3 significant figures. So, by the way, this symbol, if you're doing WebAssign, basically means it'll check and tell you whether you have the right number of significant figures or not. So you can put your answer in, then click this, and it'll say, yes, this is 3 significant figures, or no, this is not 3 significant figures. You're welcome to do that if you're using WebAssign, but the whole point is, are you getting the right number of significant figures or not? Really the only thing left in this would be, did you round it correctly? So 3 significant figures. This 0 is being used to locate the decimal. There's nothing else to the left of it, so this is not a significant figure. 1, 2, 3, 4 non-zeros, these are all significant, so we've got to get rid of this 2. And 2 rounds down, so this we would write as 0.982. Alright, next one down, all of these numbers are significant. We only want 3 of them. So this this, and this have to go away, and 3 rounds down. Anything 0 obviously doesn't do any rounding at all. 1, 2, 3, and 4 round down. 5, 6, 7, 8, and 9 all round up. So this one becomes 7,380. We have to include this 0 to locate the decimal point. This one right here, neither of these zeros have anything to the left of them, so they are not significant. Then you have these 3 numbers and a 6. So 6 would round up. So again, I still have to locate the decimal, so I'd put 0.0. 145 and 6 rounds up, so this becomes 146. Last but not least, I have this number here. All of these are significant figures. We want to round off to 3, so get rid of these 2. 2 would round down, so this should be 47.4. So now that I've written those out, I haven't actually looked at the answers to this question either. I basically, like I said, used the notepad to block that from my view. Let's go ahead and see what the assignment answers say for WebAssign. So here's the sort of moment of truth reveal. This one says 0.982, and that's what I put here. This one says 7380, that's what I put here. 0.0146, that's what I got here. And 47.4, that's what I've got here. So it looks like my answers and their answers are in agreement for this. So hopefully you found this video helpful and you were able to follow this process that I used. Here is a basic summary of whether to count the 0 or the digit in general as being significant or not. First, if it's not a 0, if it's a digit and it's not a 0, then it is significant. So 1, 2, 3, 4, 5, 6, 7, 8, or 9 are all significant. Second, if it's a 0 which is between 2 non-zero numbers, then it is significant. By the way, that also includes if there are several other zeros between the 2 non-zeros. So 910003, all 3 of these zeros are between a 1 and a 3, which are both non-zero, so these 3 are all significant. Third, if it is a 0 and there are no non-zero numbers to the left of it, then it's not significant. So 0.000. Everything to the left of this guy, 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 they're all zeros. So these are not significant. They're just there to locate the decimal point. Fourth, if it is a 0 and it's to the right of the decimal, that would be this side of the decimal, and there are no non-zero numbers to its right, then it is significant. So 0.100. There's nothing to the left of this 0, so it's not significant. Here's a 1, so that's to the left of these zeros, and these zeros are to the right of the decimal. They are therefore significant. Fifth, if you have a 0 to the left of the decimal, and there's no digits to the right of the decimal, and there's no digits to the right of the 0, then it is not significant for our purposes. So we have 3, 2, 1, 0, and the decimal place would basically go right here. There's nothing else to the right of this 0, and so it is not significant. So there's only 3 significant figures in this number. Well, I hope that you found this little video helpful in figuring out significant figures. Thanks for sending in a question, and thanks for watching. So long.